Hi guys. Hope you had a really good spring break and you're ready to start back. This will be our notes number 5, proving triangles similar. Remember when we proved triangles were congruent, we had about 5 different ways that we did that. We had definition of congruent triangles. We had side, 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 angle, angle, side, side, angle. And then we had HL. So we had quite a few different ways of proving triangles were congruent. Okay, now we want to prove triangles are similar. Okay, so let's remind ourselves what similar means. Similar means they have the same shape, but not necessarily the same size. They have to have congruent angles, and their sides have to be proportional. Okay, so there's some shortcuts we can use to prove triangles are similar that we'll address just like the shortcuts we had for proving triangles congruent. Okay, so the first one is angle, angle, similarity, and that's the symbol for similarity. Okay, this one's a postulate. Okay, and it states if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay, we're not saying they're congruent, we're saying they're similar. Okay, and if you remember, why would we only need two angles? Remember, we had the third angles postulate that said if two of an angles of one triangle are congruent to two angles in another triangle, the third angle has to be congruent. Okay, so that's why we only have to know one. So we have angle, angle, postulate as a shortcut. Okay, the second shortcut is side, angle, side, similarity, postulate. Okay, and once again, the angle is included between the two sides. So it has to come in that order. The side, the angle between the other side. Okay, so this states if an angle of one triangle is congruent to an angle of another triangle, and the sides, we're talking about the two sides that include the triangle, or include the angle, sorry, are proportional. Then the triangles are similar. Okay, so another shortcut, side, angle, side, postulate. If one angle of a triangle is congruent to one angle of another, so you're only needing one angle, and the sides that include it, so this is an included angle between these two sides. If those two sides of each triangle are proportional, then the triangles are similar. Okay, the third one is side, side, side similarity postulate. And it just says if the corresponding sides of two triangles are proportional, then the triangles are similar. Okay, so what we'll be doing today is deciding between these three shortcuts and writing similarity statement and checking that sides are proportional. Okay, so for the first example, we have, and this is not drawn to scale, two triangles like that. Okay, we're given, this one is RWS, this one is BBS. We're given 45 degrees here and 45 degrees up there. Okay, so based on what we're given, we want to know, can we assume these two triangles are similar? So if we look through our three choices, we don't have any side measurements. So if it's going to work, it's going to be angle, angle, similarity. So we have to decide, is there another angle that can be congruent that's not marked? Okay, so if you want to think about that for just a second, we'll write what we were given. Angle V was congruent to angle R. We need one more. So could we not assume those two? Remember, we want to use three letters when we name it. So I'll say WSR is congruent, and we're paying close attention to corresponding order again. BSV. Okay, and then we want to maybe give a reason why we knew that. It wasn't marked. So remember, we can say vertical angles are congruent. Okay, so then we have angle, angle, similarity postulate going on. And we can say that triangle, we can name this in any order. I'll just do WSR, is similar. And then when you write your similarity statement, you want to make sure that you're using an order that corresponds. BSB. Okay, so that may be what the assignment is today in the book that asked you to look at something, decide, are these similar, and what shortcut are you basing it on? So there's an example. Okay, example 2. And remember, these are not drawn to scale. I'm just freehanding some drawings here. Okay, for this one, we're given 70 degrees for L, 70 degrees for R. We are given side measurement 5 and 10 on this triangle, 4 and 8. Okay, so what we're given basically is we have angle L congruent to angle R. Okay, so we only have one angle, so it doesn't look like we have vertical angles or not sharing a side. So I think we're going to have to go here with side angle side if this works. Okay, so we have to compare the sides. So we're going to compare what goes together. We have JL, looks like it corresponds with SR. Those are the bigger numbers. These are the smaller numbers, KV and QR. Okay, so we're going to just see if those are proportional. Okay, so we're going to do the short side and the long side. So short side would be KL with QR, which is 5/4. Okay, if we compare the longer sides, we would be comparing JL to SR, 10/8. So are these proportional? If they reduce to the same amount, then they should be. So if I divide these by 2, I get two sides that are proportional, and it's side angle side. The angle is included. So by side angle side similarity postulate, we can say triangle JLK is similar to triangle SRQ. Now, example 3. We have STU on this triangle. This one we have VWX. Okay, our numbers were given are 8, 6, and 10. 12, 9, and 15. Okay, we're not given any angles here. So if this is going to work, I think we're side, side, side. So we're looking at the sides, and we have to decide what goes together. And sometimes they flip them or turn them, and you don't really know. So a safe bet is to put the small numbers together. So we'll just start with from left to right. ST is the smallest. And we'll correspond that with the smallest here. Okay, this almost looks like a right angle. So I'm just going to do that order and assume maybe that might be a right. XV. So I have 6/9. And then I probably want to reduce that down. 3 goes into 6. 3 goes into 9. Okay, then maybe I'll do the middle numbers. The middle number over here is 8. So I might do UT. So up here I might do WV. So 8/12. No, 4 goes into those. 4 goes into 8. 4 goes into 12. Okay. And then the longer, or the long side, the biggest number is 10. So US looks like it's corresponding to WX. So I have 10 correspond with 15. Okay, I know 5 will go into 10. 5 will go into 15. Okay, so it looks like they're all proportional. They all reduce to the same thing. So I have side, side, side similarity postulate. And triangle, we can give a statement. SUT is similar to triangle XWV by side, side, side. Okay, and if they ask for the similarity ratio or the scale factor, it's 2/3. Okay, and then our last one here, sometimes they share sides. Draw that a little better. Looks like I have a little triangle and a big triangle. They got to have the same shape, but not necessarily the same size. So I got a little and a big. Okay, so this little one has KLP, and the big one is KMN. And the numbers I have are 8 here, 12 here. They're given a 2. Now that 2 just represents this distance. And then down here, I'm given this distance as 3, P to N. Okay, remember, it's not drawn to scale. Okay, so do I have an angle they have in common? I have the little triangle that has angle K. I have the big triangle that has angle K. So would angle K be congruent to itself? Bireflexive. So there I've got a congruent angle. So I could maybe go with side angle side. Okay, then we need to compare the sides. So I have a little triangle and a big one. Okay, this side KL goes with this whole big side. So KL goes with KM. So I have 8 on this side, and then the whole thing is 10. And then 8/10 reduces 4/5. Okay, and then on this side I have KP going with KN. That's the small side of the triangle and the big side. So the small side has 12. The big side's both of these together. Okay, and then if I divide those both by 3, looks like I have side angle side similarity postulate. So triangle KLP is similar to triangle KMN. Okay, well, I hope this helps, guys. And then, like I said, if they ask for similarity ratio, Orpheus, or the similarity, or the ratio, or I think the other word, I don't know, I'm at a loss. But anyway, guys, there's some examples. I hope that helps you guys, and I'm sure that that's enough to go on for today's assignment. I miss you guys, and I hope you have a good day. Thanks.